Fast-moving object the size of Manhattan is hurtling towards our solar system, comet, asteroid, or something else. Astrophysicist believes there's a strong likelihood this is a craft of alien origin. For the first time ever, we're about to see what happens when an alien traveler crosses paths with the sun's fury. A huge coronal mass ejection burst off the sun's surface this week, and instead of heading toward Earth, it lined up perfectly with the 3I Atlas. You floated the possibility that 3 Atlas is alien technology in order to distract us from the Epstein 5. What happens when a storm born from the sun collides with an alien traveler? And what hidden secrets might that collision uncover? The sun strikes back. The sun doesn't ask permission when it loses its temper. Earlier this week, a violent wave of energy burst from its surface, carrying billions of tons of superheated plasma and twisted magnetic fields. Astronomers call these eruptions coronal mass ejections, and they are among the most destructive forces in the solar system. The blast raced outward at speeds faster than 1,000,000 km/h, spreading in all directions like an invisible tsunami. On Earth, we worry about these storms frying satellites, knocking out power grids, and lighting up the sky with aurora. But this time, the Earth was never in danger. This time, the storm was headed for something far stranger, an interstellar wanderer known as 3I Atlas. That name tells a story. The 3I marks it as the third interstellar object ever confirmed. The first was one Oumuamua in 2017, the mysterious shard that slipped past us before anyone could fully understand what it was. The second was 2I Borisov in 2019, a comet with a long glowing tail that felt more familiar, and now 3 Atlas, discovered in July 2025 by the Atlas Survey Telescope in Hawaii. It is no small visitor. Early estimates suggest its nucleus stretches nearly 5 km across and carries more than 30 billion tons of mass. To put that in perspective, this one body is heavier than all the water in the Great Salt Lake combined. Even more intriguing is its chemistry. Unlike many comets in our solar system, which give off mostly water vapor, 3I Atlas shows a higher ratio of carbon dioxide, making it a true outsider in both origin and makeup. And right as astronomers began tracking this rare alien traveler, the sun decided to hurl a coronal mass ejection directly into its path. The timing could not have been more dramatic. Instead of a quiet passage through our skies, 3I Atlas is about to be tested against the raw fury of our star. No simulation can predict exactly how it will react. Will the sun rip away its glowing tail? Will it trigger unexpected bursts of brightness as hidden layers boil into space? Or will this ancient traveler shrug off the strike, carrying on its endless journey as if nothing happened? A stranger in our skies. When astronomers first spotted 3I Atlas, it didn't take long to realize this was no ordinary comet. The discovery came from the Asteroid Terrestrial Impact Last Alert System, or ATLAS, a sky survey designed to catch dangerous near-Earth objects before they get too close. On that July night in 2025, the telescope picked up a faint moving speck against the background stars. At first it looked like a routine detection, but when the orbit was calculated, jaws dropped. The trajectory was not looping back around the sun like a native comet. Instead, it was open, hyperbolic, the unmistakable signature of an object from beyond our solar system. That single curve in its path told astronomers that this visitor was born in another star system and was just passing through ours for the first and only time. The numbers made it even more impressive. Unlike 1I Oumuamua, which was relatively small, and 2I Boris, which resembled an average comet, 3I Atlas appeared to be enormous. Early estimates suggested its nucleus could span almost 5 km in diameter. If true, that makes it the largest interstellar body ever detected so far, and its mass, more than 30 billion tons, gives it a stability and resilience that sets it apart from its predecessors. This was not a fragile ice shard drifting aimlessly. This was a mountain of alien ice and rock plunging through the solar system with momentum built up over untold millions of years. Then came the chemistry. Using spectral analysis, astronomers detected an unusual ratio of gases venting from its surface. Most comets near the sun release water vapor as they heat up, but 3 Atlas gave off a stronger signature of carbon dioxide. That might sound like a small difference, but it hints at a very different origin. In another star system, conditions must have favored the preservation of CO2 ice more than water. That makes 3I Atlas not only a rare visitor, but also a messenger carrying with it the fingerprints of the world where it was formed. Every particle it sheds into space is a piece of a puzzle we have never solved before. The CME that changed the story. On September mornings, space weather forecasters watch the sun like storm chasers watch the horizon. Satellites like SOHO and the Solar Dynamics Observatory are constantly scanning the corona, the sun's outer atmosphere, for eruptions. Earlier this week, the warning lights lit up. A bright flare blossomed on the surface, and within hours, instruments detected a full coronal mass ejection, a bubble of plasma exploding outward. These events happen often, but the direction is everything. Most shoot harmlessly into empty space. A small fraction head toward Earth. But the trajectory of this eruption was unusual. Calculations showed that the bulk of the blast was moving straight along the same path where 3I Atlas was cutting through the inner solar system. For once, Earth was a bystander. There would be no threat to our satellites or power grids. Instead, the storm was on a collision course with an alien object that had only recently entered our neighborhood. The timing was eerie. Astronomers had barely had weeks to gather baseline data on 3 Atlas when the sun decided to fire off a storm in its direction. Some compared it to nature handing them an unplanned laboratory experiment. They didn't need to design it. The sun had already set it in motion. The numbers behind the coronal mass ejection were staggering. Billions of tons of charged particles, streaming at speeds of more than 1 million km/h, magnetic fields strong enough to twist and snap like rubber bands when they collide with other magnetic environments. On Earth, this same kind of event can supercharge auroras to glow blood red as far south as Florida. On a comet, the effect is completely different. The tail of a comet is made of ions and dust, fragile streams of particles pushed by solar wind. When a CME slams into it, the tail can bend, shatter, or even rip off entirely. For a body like 3 Atlas, that meant its delicate veil of gas could be stripped away in an instant, leaving behind a raw view of its core. The predicted impact zone. Imagine the solar system laid out like a giant cosmic highway. The planets circle in neat, predictable lanes, each locked to the gravity of the sun. Then there's 3 Atlas, an outsider cutting across all those lanes at a sharp angle, racing through like a trucker who doesn't belong on the road. By late September, it was moving just inside the orbit of Mars, its long tail glowing faintly against the black. That was the exact moment the sun chose to spit out a storm. A coronal mass ejection burst free, spreading wider and wider until its invisible shockwave began sweeping toward the same region of space where the comet was flying. The timing was uncanny. If 3 Atlas had been only a few million kilometers ahead or behind, it would have missed the storm entirely. Instead, every projection showed the comet and the CME intersecting like two runners colliding at the same finish line. The predicted impact zone wasn't near Earth, wasn't near the Moon, and wasn't even in Mars' immediate path. It was a lonely patch of interplanetary space, quiet and empty, except for one alien visitor and a storm big enough to stretch across millions of kilometers. The sun had drawn a straight line, and 3 Atlas was unlucky enough to be sitting on it. From Earth, the setup created a strange kind of tension. Telescopes could see the comet, but only barely because it was sliding closer to the sun's glare. The best windows for observation were shrinking by the day. Astronomers scrambled to point instruments at the target, knowing that in a week, maybe less, 3IA Atlas would vanish into daylight. For them, the predicted impact zone was not just a place in space. It was a race against time, a narrow corridor where a solar storm would collide with an object from another star, and either nothing noticeable would happen, or everything we thought we knew about comets would be rewritten. Lessons from Encke. This wasn't the first time a comet had crossed paths with the sun's fury. Back in April 2007, something remarkable happened to a small but well-known body called Comet Encke. As it moved along its orbit, a powerful coronal mass ejection slammed into it. For astronomers watching through solar observatories, the scene looked almost unreal. The comet's tail, a bright streamer of gas and ions stretching millions of kilometers, simply broke away. One moment it was there, connected like a glowing tether to the nucleus. The next moment it was sliced clean off, torn away by the impact of the sun's magnetic storm. Within minutes, the comet grew a new tail, as if nothing had happened. But the event was a wake-up call. A CME could disconnect something as vast as a comet's tail in seconds. Now take that memory and apply it to 3I Atlas. Enki was small and local, part of our solar family. 3 Atlas is larger, heavier, and carrying the chemical fingerprints of another star system. Its tail, faint and bluish, streams outward as carbon dioxide and dust are blown away by solar radiation. A coronal mass ejection slamming into that kind of structure is like throwing a hurricane against a silk banner. The fragility of the comet's ion tail makes it almost certain to be disrupted. Astronomers were already predicting what they call a disconnection event, where the tail snaps and then reforms as the CME sweeps past. But with an interstellar body, the unknowns multiply. No one has ever seen a tail built of alien chemistry meet a solar storm before. That is why this moment matters so much. If the CME strips the tail, telescopes may capture the exact rate at which it rebuilds, revealing how the comet's gases respond to solar energy. If the storm stirs up deeper layers, we might glimpse fresh material venting into space untouched. Since the object left its home system, it is more than just a flashy show in the sky. It is the kind of natural experiment scientists could never stage on their own. Enki gave us a preview of what the sun's power can do. 3I Atlas is about to show us how far those effects reach when the target is not from this solar system at all. The comet's shield. When people hear about a solar storm slamming into a comet, the first thought is often impact like a meteor striking a rock. But a coronal mass ejection isn't a solid object. It's a flood of charged particles and magnetic fields rushing through space, invisible but immense. To understand what 3I Atlas is facing, you have to imagine the scale of both forces. On one side, the CME carries billions of tons of plasma, a river of electrified gas stretching millions of kilometers wide. On the other side sits a nucleus the size of a mountain nearly 5 kilometers across with an estimated mass of more than 30 billion ton. It is a battle between something light but sprawling and something heavy but compact. The truth is, the storm will never threaten the core of 3I Atlas. The comet is simply too massive to be nudged off its trajectory by a CME. The orbit it follows through the solar system, carved out by gravity, will stay the same. The real battlefield is the surface and the atmosphere surrounding the comet. The plasma wave will hammer into its coma, that cloud of gas and dust that boils off the nucleus as it heats near the sun. Magnetic fields carried by the storm can twist and strip the coma, snapping lines of charged particles and flinging them into space. It's like watching a fire hose slam against the mist from a waterfall. The waterfall itself doesn't move, but the spray is scattered in every direction. What makes 3 Atlas so intriguing is its alien chemistry. Unlike most comets we've studied, this one releases a high ratio of carbon dioxide compared to water vapor that changes how its coma behaves. Carbon dioxide gas escapes more violently when heated, producing jets that can punch holes in the dust cloud. If the CME sweeps through those jets, the reaction might be sharper than anything we've seen before. The sunstorm could peel back layers of activity, exposing deeper reservoirs of gas trapped inside. Since the comet formed in another star system caught between telescopes, the timing of the strike could not have been more frustrating for astronomers. 3 Atlas was sliding deeper into the sun's glare, heading towards solar conjunction. From Earth's perspective, that meant the comet was creeping closer to the bright edge of the sun in the sky, where ordinary telescopes risked being blinded. Observing it became a race against time. Ground-based observatories tried to stretch their limits, squeezing in data during the narrow hours when the comet was just far enough from the sun to be visible. But even the largest mirrors on Earth were straining to capture more than faint noisy signal that left the job to space-based eyes. The Hubble Space Telescope could track faint gas tails, but its scheduling was already crowded. The James Webb Space Telescope far out at the L2 point had the sensitivity to measure the chemical fingerprints of the comet's coma. But Webb has strict rules about pointing too close to the sun. Instead, the best hopes fell on solar observatories themselves. Missions like SOHO, Stereo, and the Parker Solar Probe, which are built to stare at the sun and its environment. These spacecraft might not have been designed to study comets, but their vantage point meant they could actually catch the collision between the CME and 3I Atlas. Then came the amateur networks across the world. Smaller observatories and backyard astronomers followed every scrap of news, ready to contribute. Their telescopes would never capture the storm itself, but they could track changes in the comet's brightness. The sudden disappearance of a tail or the flicker of a disconnection event. In the age of instant communication, even a small observatory in a rural field could upload a data point that fits into a global picture. Solar system politics. In astronomy, discoveries are supposed to belong to everyone. But when something as rare as 3I Atlas gets tangled up with a solar storm, the question of who gets the first look becomes a quiet competition. Every major space agency wanted a piece of this event. NASA had its solar fleet watching from multiple angles. The European Space Agency had its own instruments primed for the blast. Chinese observatories, both ground-based and orbital, were tracking it closely. Even the Indian space program, with its growing presence in planetary science, had scopes trained on the interstellar traveler. Officially, data is shared through scientific papers and public releases. In reality, there's a race to publish first to be the team whose names go down in history as the ones who captured the moment the sun struck an alien comet. Attention didn't stop with governments. Private telescopes and commercial space companies now own hardware in orbit. Some of them had cameras capable of picking up changes in brightness. For them, the opportunity wasn't just science. It was publicity. Being able to say they caught footage of the first CME to collide with an interstellar comet could put a company's name across every news feed in the world. That meant more funding, more investors, and more prestige in an industry where visibility is everything. Even among professional astronomers, there was unease. Sharing raw data too quickly could mean someone else publishes an interpretation before you do. Waiting too long risks missing the global conversation entirely. It became a delicate balance. Who would claim the first evidence of a tail disconnection? Who would reveal the first spectra showing alien chemistry stripped bare by a solar storm? The alien comet question. Every comet carries a story about where it was born in our solar system. Most of them formed in the icy outskirts in places like the Kuiper Belt or the Oort cloud. Their chemistry reflects that heritage, with water ice, carbon monoxide, and dust mixing into familiar patterns. But 3I Atlas is different. Its spectrum reveals far more carbon dioxide than water, a ratio that doesn't quite match the comets we know. That single detail is enough to mark it as an outsider, built-in conditions our own solar system never offered. And when a coronal mass ejection slams into that kind of alien chemistry, the outcome becomes unpredictable. If the storm rips through its coma, it may peel back layers of material that haven't seen sunlight for billions of years. Fresh gas could erupt, glowing brighter than the surface ever has before. For astronomers, that's a priceless opportunity. Each molecule released into space carries a fingerprint of the star system where 3I Atlas form. It could tell us whether the mix of elements is common across the galaxy or whether our solar system is truly unique. In a way, the CME acts like a cosmic drill, punching into the comet's shell and forcing it to reveal its hidden reserve. The questions go even deeper. If interstellar comets like 3I Atlas carry exotic chemistry, what does that mean for planets orbiting other stars? Could those building blocks seed life if they crash into a young world? Or could they carry toxic compounds that snuff it out before it starts? Every cometary fragment is more than just ice and rock. It's a sample container drifting through space for millions of years, waiting for something, in this case the sun, to open it. The alien comet question is not just whether 3IALs will survive the storm. It's whether the material it reveals will expand our understanding of what other star systems are capable of creating. And in that sense, the sun's violent outburst has become an unplanned experiment in galactic chemistry, one that may rewrite how we imagine the ingredients of other worlds. That's it for today. What did you think about this insane update on 3I Atlas? Let us know in the comments down below. Don't forget to like and subscribe for more space content.